Ladies and gentlemen, hello and welcome to the Inside Analysis Big Data Ecosystem Marketplace. We're pleased to have with us today David Bessemer. He's Head of Strategy and Technology for the Cisco Data Virtualization Business Unit, and he's about to give us a demo about the Big Data Warehouse expansion that they've been working on over at Cisco. David, the floor is yours.
Thank you very much. It's a pleasure to be here. And one of the offerings that we've brought to market is around trying to reduce the cost of ever-growing data warehouses by leveraging some of the newer Hadoop ecosystem for low-cost storage, and then using data virtualization as a way to bridge these different silos of data. So if I draw this architecturally, in the traditional mode, you might have a data warehouse and probably have some reporting software and maybe some analytics software that sits on top of it. But as the volume increases, of course, the cost increases, and the warehouse also tends to slow down. So if you can offload some of the colder data, maybe some of the older data, to less expensive storage that might be on something like Hadoop, then you can start to save on your data warehouse costs and really create an ecosystem where you have essentially unlimited storage. The way we used to do this, of course, is archive the data from the warehouse to tape, but the main problem with that is it made it completely inaccessible for practical day-to-day queries. Whereas if we move it over to a warm environment like Hadoop, then you can put data virtualization above the Hadoop ecosystem and the data warehouse ecosystem and allow your reporting and analytics and applications to continue to use the data as if it were all in one place, but in fact it's partitioned across the warehouse and the Hadoop cluster. And of course, once you have data virtualization in place, you can also combine it with other data around the enterprise, so this architecture actually gives you flexibility beyond just offloading data from your warehouse. So today, I want to demonstrate a very simple form of this. I have an enterprise data warehouse, and it is the complete warehouse, but some of the data has been offloaded to a Hadoop cluster. And typically, this is data that grows and grows and grows, things like orders and transactions. You may continue to keep more reference data simply in the warehouse, and you might even replicate that to Hadoop. But the idea is to keep as long a history as possible that's available for querying. And so you can start to offload orders and the details about those orders and other things to the Hadoop cluster. And just to make this more interesting, we've also decided to use a Hadoop cluster that's in the cloud. This is a possibility for companies who are doing this to actually, instead of deploying the Hadoop cluster themselves, to actually put it in one of the cloud infrastructures. So the first thing we've done is we've looked at the enterprise data warehouse, and in this case we've got a view called order line items current, and this is essentially a join of three tables, which is the orders, the detail, which are the line items, and then products, just to get some reference data in there like product name. What we've left in the warehouse are the current year, so 2014, and the prior year, so all of 2013. So you always have at least a full year, and then of course when we got to 2015, then we would move 2013 into the Hadoop cluster. We then created the same tables over in the Hadoop cluster, and all of the data that's older than the prior year, so in this case older than 2013, exists in the Hadoop cluster. What we're building up to here is we want to be able to do an analysis of which products are selling well over whatever time period we choose. And so above these two different systems, we'll actually create a union of both of these and create an order line items view that actually combines data from both of these and presents that as reportable to whatever consumer is using it. And so this is the view, if you will, or the table that would be available to analytic users and BI reporting users. So then to fill out the demo, we'll actually do a sample query where we will look for sales by product, so that we will query the whole system. We'll group by product. We will do a summation and aggregation on the sales. We will also do an aggregation on the number of items ordered, so that we get a count of actual products ordered. And we'll constrain that by the order date, so that we can see how the system behaves as you query the current system or you query both systems. Okay. So let me switch from PowerPoint over to a live Cisco Information Server Studio. And this Cisco Information Server Studio is connected to a Cisco Information Server. And over here on the left, we have the typical resource tree of various items. We have two databases here. One is the Enterprise Data Warehouse, and one is the offloaded Enterprise Data Warehouse in Hadoop. And if I open up the Enterprise Data Warehouse, you can see there's lots of tables, lots of views, various things. You know, you can always just look at some data in here. So you can say show contents, and it'll do a quick query on that table. So that's product categories. And the idea here, of course, is that you have access to the entire data warehouse. We've offloaded 4 tables: products, orders, order details, and categories. And the 2, of course, that continue to grow are the orders and orders details. Right? Now, on each of these different sources, we've created a view. One of them is called Order Line Items Current, and that, of course, shows that join that I showed you before. And you could run this and actually get some information back from the warehouse. You can see that it's very speedy and includes a couple of derived columns. There's a subtotal there. And then we've created the same view over on the Hadoop version of this. Now, I'm not going to press the execute button here because this is a Hive instance running in the cloud. And so even though it can be massively parallel and process huge amounts of data, the overhead for doing those queries is about 45 seconds. And once you actually incur that overhead, you can process a tremendous amount of data, but we'll only do that once here during the demo. So then what we've done is we've taken these 2 views that combine those tables in the different data sources, and we've created a single view that's essentially simply a union of both of those. Okay. And then on top of that, we're creating a sample query on the order line items. And if I look at the SQL for this sample query, we're actually doing a group by on the product, and then we're summing the quantity and the subtotals, and we're also looking at the last order date. And we're constraining that by a particular date. Okay? So if I go ahead and run this, it comes back very quickly. And that's because as we look at the current constraint says I want everything that's within the last year, which is July 25th, 2013 until the present. So it's essentially saying, show me everything where the order date is larger than or equal to that date. And so when the Cisco Information Server query engine takes this query and runs it against that union of the current data in the warehouse and the offloaded data in Hadoop, it's smart enough to look at that date and say, oh, I know what the horizontal partitioning parameters are between these 2 data sources, and I know that I will never get any data out of the Hadoop cluster because this date is after the date of the data that's in there. And so it actually turns that half of the union into a null scan and doesn't actually even query that. If we change this and change it to, let's say we wanted to look at 2 years worth of data, and we run this again, this is where we'll actually incur the 45-second delay because the optimizer says, I not only have to query the warehouse, which of course would be relatively speedy, but I also have to query the cloud-based Hadoop data source. And so a Hive query has been issued, and it's off doing its setup and processing, and in about 30 more seconds, it will come back with the result. Now, if you think about that for a minute, incurring 45 seconds on these kinds of queries during a demo like this seems like a lot. But if you think about the ability to have 10, 15 years of data sitting in that Hadoop cluster and the ability to query that live without having to change anything, you can see our queries back now, without having to change anything, that is a really important aspect of isolating your data consumers from the actual topology of how you're storing this data and potentially offloading it on a monthly or yearly basis. So you can see down here that we've sorted this by total revenue for each product. So we've got some products up here at the top, but if we go down to the end of the result set, you can see that things like long life tofu just aren't selling very well. Can't imagine why. So, and again, if I change this and say, well, let's say we just wanted to look at the current year, so we'll change this to 2014, January 1st, and we can run it again, and it comes back very quickly. And let's just scroll down to the bottom here and see what our worst selling products are. And it looks like long life tofu is doing a little bit better, but the hot spiced okra is really the worst selling product this year. Okay. Now, of course, we're doing all of this in the Cisco information server, but you can obviously use this from any tool of your choice. And we could go over to Microsoft Excel, for example, and just do a query through Microsoft Query. I've got a DSN set up here, and there's my different tables that I've published. And I'll just do this sales by product, which currently happens to be set up for the current year. And we can finish that, and that same data shows up here in Excel. Okay, so from an Excel user standpoint, or Tableau, or business object, there's no knowledge whatsoever that the data in this query may or may not be coming from multiple data sources, one of which is a Hadoop cluster that's running in the cloud. Okay. The other thing that you can look at in here, Robin, in our discussions earlier, talked about the idea of lineage and how can you actually see where data is coming from when you start to have it distributed around various places. And so we can actually bring up a lineage panel here, and I can take this full screen, and you can look at any column in the final view, in this case the order line items view or the sales by product view, and you can trace it back to whether it came out of the Hadoop or the warehouse instance. Okay, and so if we ever wonder where we collapse some of these to make it easier to look at. Okay, so here's the enterprise data warehouse. We've got orders, products, order details. Here's the Hadoop instance. We've got order details, orders, and products. Product has been cached because it doesn't change, but the orders and orders details come straight out of the Hadoop, and then there's the two different views on top of those and the union, and eventually you get down to the actual query. Okay, so that's the demonstration of the ability to offload some of your enterprise data warehouse data to a Hadoop cluster and yet still maintain the ability to query both of them as if it were a single source.
Well, it looks fairly simple, to be honest.
Good.
I think that's perhaps, you know, part of the charm of it. It looks as though in order to organize this, it wouldn't take much. I mean, in terms of, you know, when you actually put this into action, what is the you know, the bedding in curve between, you know, delivering the product and people properly understanding how to use it? Do you have any kind of, can you give us some kind of guideline on that?
On kind of the learning curve and coming up to speed and the deployment time?
Yeah.
Yeah. So a couple of things. You know, Bob talked a little bit about the idea that in order to really do this effectively, you have to do some analysis of your warehouse and determine what are the things that really should be offloaded. And so one of the first things we do is we take a few months to actually put some instrumentation on the warehouse and do some profiling and evaluation. And so that's kind of a few months of upfront, let's make sure that we understand what's the proper data to actually offload. Once we actually determine a plan for what data is suitable for offloading, the actual time to offload and get you up and running is actually very fast. You know, data virtualization is quite an agile technology, and so within a few weeks we can actually get you set up with a Hadoop cluster and offloading data over to it and have some views that are sitting above the horizontally partitioned data. Now, one of the things that you do is you do this incrementally. It does not have to be a big bang, boil the ocean type operation. So generally what we'll do is we will first layer the data virtualization system in place so that the queries from the reporting and analytics are now going through the data virtualization layer. And that's generally a very easy task because these are all standard SQL queries and they all understand SQL 92. And then you can start to migrate data and relinking and creating these horizontally partitioned views. And you can do that very incrementally, one archived or offloaded set of data at a time, so that you can not only get used to this new way of operating, but you can also see what impact it has on the users who are actually doing the reporting.
Oh, that's interesting. So in terms of the companies that have adopted the technology, it seems to me that, you know, you can use this technology, quite clearly you can use this technology in one way or another, because you have a very specific problem that you need to address, where data virtualization really does give the best way of getting you out of the situation you're in. But there's also a strategic aspect to a product like this. And I wondered if you could kind of just speak in, you know, fairly briefly, but in the strategic deployment of this product and what that kind of looks like.
Yeah, you know, it's interesting, Robin, as we move from the traditional monolithic data warehouse, which was the focus of data integration for a long time, to a world where we live in a distributed collection of data silos, some of which are on premises, some of which may be in the cloud, some of which may be at partners. In order to really handle that, you really need to put some kind of logical overlay above all of these sources that allows you to create a semantic layer that gives you access to all of this data no matter where it lives. You know, the days of where we replicated data all over the place are over and should be over. It was a tremendous cost to do that. Data became disconnected from its source of record, and over time, you really just lost control of this spaghetti mess of copies of data. So in the new world, the challenge is to figure out where is your golden source, and maybe you've partitioned that across multiple, but whatever it is, decide that, and then put an overlay above all of this and query it on demand and integrate it on demand and deliver it to the users.
Well, this has been great, and ladies and gentlemen, again, we've been listening to David Bessemer of Cisco Data Virtualization discussing how their big data warehouse expansion really fits into the big data ecosystem. And David, thanks so much.
Thanks very much for having us.